Find the appropriate critical value for a test of the following claim at the 5% significance level. The data used to test the claim involved a random sample of 10 measurements. You may assume the measurements follow a bell-shaped distribution. And they tell us that the claim is that the mean is equal to 0.52. All right, so let's start with this initial idea here that if the claim is that the mean is equal to 0.52, then the null and alternative hypothesis are as follows. And because the alternative hypothesis has a not equal to sign, we're dealing with a two-sided hypothesis test. So let me just draw a bell curve as a visual aid here, right? It says the data follows a bell-shaped distribution, so I think that's appropriate. And we'll draw two tails on that curve, place a 0 in the center. Now the question is this a z distribution or a t distribution? In other words, what distribution would our test stat have? Well, because of the small sample size, we'll go ahead and assume that it's a t distribution. So I want to label this axis down here a t-axis and not a z-axis, and that's because of the small sample size. From there, I'm also going to recognize that the area in those tails collectively is 5%, which means half of it in each tail is only what? 0.025 or 2.5%, right? So that's the area in each tail. Now, the other thing we need to remember is that when we're dealing with something like a t-test, we have to use degrees of freedom. So if n is 10, the degrees of freedom is going to be 9, 1 taken away from that 10. So we're going to go ahead and call that 9, right? So the degrees of freedom here is simply going to be 10 minus 1, and we need to include that in our drawing. Okay, so the degrees of freedom is 9, the area in one tail is 0.025. Let's go to the t-table then to find the corresponding critical value. So here we are in the t-table, we're looking at 0.025. We're going to come down to where we have 9 degrees of freedom, and we get the answer 2.262. So 2.262. So that means this part here is 2.262, or that's the beginning of that rejection region. And this one over here is negative 2.262, right? So this is the t critical value we just found. And that means that essentially we have two critical values, right? It's plus and minus 2.262. Okay, so that's really the only difference between the t-test and the z-test, that we have to essentially use degrees of freedom when we find our critical value. Working out a t-test, we really do everything else the same as we did with the z-test, except for we have to use degrees of freedom when we go down to find our critical value. So instead of going straight to the bottom, we stop a little short. That's all.